Um, okay. That was strange. Are we still up? I have no idea what happened. I mean, OBS said it was still streaming. It just ended here. That doesn't make sense. Hope it doesn't happen again, I guess. Can do that. Yes, cool. All right, well, I think we're done with this problem. For the sake of practice, let's go through it again. Degrees greater than or equal to 4, or degrees greater than or equal to 3 or 2 are not leaves, then we win automatically. Otherwise, if none are colored, then it's a draw. Because we have this special kind of graph. If we have colored degree greater than or equal to 3 or adjacent to that, then we win. If we have colored degree greater than or equal to 2, or 1 is not a leaf, then we color that one and we win. So if we have colored anywhere on this special graph, then we win. Else n is less than or equal to 3 or only leaves are colored. How would this work here? Colored degree is greater than or equal to 2 or 1 is not leaf. W. Else n is less than or equal to 3 or only leaves are colored. If n is less than 3, then draw. Otherwise, if n is greater than or equal to 3, then we win if 2 are colored, because we can just color the other one. Otherwise, draw. Hello, again. I guess again, yeah. Whatever the hell happened last time. Very fun. Otherwise, we could have one leaf colored and then you could be like here, right? It's like, suppose you're even, right? So we could color this, then this is pointless. Or we could color this, then you'll block this out. So we could color this, then you'll block this out. Wait. No, there's something else, isn't there? Yeah. So you can be distance 2 from here. But if you're distance 3, then if we have odd distance to a special vertex, okay, so if we have odd distance to a vertex of degree 3, then we can color you. You'll be forced to color this. Then we win. If you have odd distance, right? If you have odd distance, then we can color adjacent. Yeah. Then 2 leaves colored, W if and only if even distance. Okay. Okay, cool. This is stupid, but here we are. This problem is, okay. Cn to n. So, for Li0 is an n, C into S. So pre-check. Bool pause equal to 0. Edge I dot size is greater than equal to 4. CT is 0. 4 Lx edge I if edge x dot size is greater than 1 plus CT. Pause or equals CT is greater than equal to 2. If pause okay. CC okay, otherwise. Bool pause equal to edge I dot size greater than equal to 3. Colored deg greater than or equal to 2, where 1 is not leaf. I dot size is greater than or equal to 2, and CT is greater than or equal to 1. If pause, CN white. n is greater than 3 if n is equal to 3. Okay, otherwise, so if d is greater than 0 and d mod 2 is equal to 0 and SV is equal to W, can is equal to 1, d mod 2 is equal to 1, and edge v dot size is greater than or equal to 3, can is 1. DFS x v d plus 1. Okay, so I guess that's it. The stream's still up? Cool. I guess that's the thing. I don't know why that happened, but whatever. I guess that's a thing we have to think about now, right? That's cool. Tic-tac-toe game, yeah. Okay, so let's look at everything again. So degree greater than or equal to 4, degree greater than or equal to 3 or 2 are not leaves. Edge I dot size greater than or equal to 3. Pause, yeah, white. Otherwise, we have the special graph, which we cannot win on. Okay, so colored, degree greater than or equal to 3, or adjacent to degree greater than or equal to 3, or not, or degree greater than or equal to 2 and adjacent to something that's not a leaf. If any of those are true, we win. Otherwise, either n is less than or equal to 3 or only leaves are colored. So, small cases, if n is less than 3, draw. N is equal to 3, CC is greater than or equal to 2, print white, otherwise print draw. Now, otherwise, if 2 leaves are colored, we win if they're even distance to each other. If 1 leaf is colored, we win if it's an odd dist to degree 3. Right, because we have this, so we can color U. Black will be forced to color this. Then we color this, and then we win. If 2 leaves are colored, if they're odd distance, then there's nothing we can do. Black will always get rid of our advantage. They'll stay odd distance. If they're even distance, then we will win. If they're even distance, then right, then we color U. And eventually we color this, and then eventually we win. Okay, so we check D is greater than 0, and D mod 2 is 0, and SV is W. Can is 1. If d mod 2 is 1 and edge v dot size is greater than or equal to 3, can is 1. Okay. I guess that's it. I don't know, man. I guess that's it. Is this gonna work? I mean, I've shown that it's sufficient. Ugh, great. Every test case, print either white, jar. So what have I missed? Have I miscoded something, or have I missed something? C into n for I is 0 up to n, edge I dot clear for each thing. So we're reading all the input. Problems like this, man. Bool pause is edge I dot size is less than or equal, is greater than or equal to 4. So if we have something with degree at least 4, we just win automatically off the bat. Because I mean, we just do. If we color U, there's nothing you can do now. We just win. Or if we have degree at least 3 and 2 non-leaves, and we color in that direction, and then we win. If edge x dot size is greater than 1 plus ct, pause or equals edge I dot size is greater than or equal to 3 and ct is greater than or equal to 2. If pause, print white. Otherwise, C is equal to W. So if we don't have anything, then we cannot win on this graph, right? Black's gonna color this. Wait, hang on. Wait. Can we? Wait, maybe we can actually. Wait, can we win on this graph? Can we win on this graph? Suppose we color this. Suppose we color this. Black's gonna block this one. Okay, suppose we color, if we color this, black's gonna block this one, so that's dumb. If we color, okay, wait, yeah, I missed the case, damn. Okay, that's fine. If we colored this, allow CS is 0. If CS is equal to 2, so if we have this, CS is 2, right? If we have this, we color this, black must block this or he loses. Then we color this, and black must block this. Yeah, okay. If n mod 2 is equal to 1, yeah, that is a case I missed. Right. If n is even, and we have a graph like this, then we color this, then black can block this, then we color this, then black can block this. Yeah, okay, yeah, sure. All right, let's try again. Cool. What a problem, man. What a problem. What a problem. What a weird problem. Weird and unusual, and I don't know why that. Okay. Cool. 3100. Yeah, fine. Be that way. It's just like annoying. Like, why did they make us do this? Why do you? Who finds it fun to do this? Who finds it fun? And I mean, you can make it a necessary and sufficient thing to, like, do stuff, but blah. Okay, and the reason I missed that case is because I realized this was a thing later, but then I didn't think about how it affected this. So yeah. So then we do this. And black must block this. Then we do this. And black must block this. And then we win. Yeah, that's cool, man. That's really cool. What a cool problem. How cool. Lovely. Anyone else had fun with that? Anyone else have fun? So H has 0 solves, right? Solved by an unrated in 10 minutes. Yeah. H has 0 solves. Okay. So we're not touching that. Wrong answer on pretest 14. The hell? How do you do that? Okay, sure. How big is... Wait, how do you do that? How big is pretest 14? Are you like a massive test? Or are you like bigger tests? No, it's 40,000 cases, but it's like all of them. Okay, sure. Really cool problem, man, and people didn't get it because they ran out of time. That's why, right? That's why. That's why people didn't get it, because you can't do that if you have such little time left. Yeah. That's cool, bro. Cool story. Really cool story. H has no solves, right? Yeah. Not even rainbow. Actually, Rainbow didn't even start rainbowing before this round. This round predates Rainbow, by the way. That's how old we're getting. Like, he started rainbowing last page, I think. I think the round where I solved problem from Red Panda. Where was that? Not this one. This one. This one was where Rainbow started rainbowing. This is the first one, I'm pretty sure. It was, right? Yeah, this is where he started doing it. Pre this, he didn't. It's interesting. Bit of history. Yeah, so okay. It's sad that I missed a case, I guess. But whatever. I don't have any jokes on hand, sorry. That's not the type of stream this is. This is an entertainment stream. He paints some path of 3 vertices in his color. In case all vertices are... Yeah. What are we doing? Okay. Man. Just 12 lines of notes. Just all different cases. So if we have the special graph, right, then black is forced to block here. So we reduce n by 4. And we can place here, and we reduce n by 2. Until n becomes 3, and we have an advantage, yeah. And if n is 4, then we can't do anything with it. So the only way we force black to do that is if we do that, but then we lose. And if we do this, then if we do this, then black wins. If we do this, then black has to do this, and then we win. Yeah. God, what a problem. What a freaking 3100, man. F. Yeah, it wasn't worth it. Okay. Alright, now we go back in time. Oh, this is the grid game round. Okay, well, we can do D, I guess. And then E has 1 solve. Yeah, maybe not. Maybe we don't touch E. We can look at D, though. Is it interesting? Let's just read it. Define radix sum number A consisting of digits A1 to AK. Number B. Number S. You're given an array x1 to xn. So the radix sum of these integers is equal to I. Radix sum of number A consisting of digits A1 to AK. So the radix sum of these integers is equal to... So it's some strange convolution, right? That's what we're doing here. Some strange convolution. Consequently, choose one of the integers from the array n times. So the radix, okay, screw it. Nah. This is convolution. Like, I don't want to touch that. Card Bluff is a popular sport game in Telegram. Each Card Bluff player has dreamed about entrance in the professional layer. There are n judges now in the layer. You're trying to pass the entrance exam. You have a number K. Each judge has a number AI, a number EI, and experience playing Card Bluff. To convince all judges by playing with them. You can only play one game with each judge. As a result of a particular game, any natural divisor of AI, which is at most K, if GCD of all indicators is equal to 1, play with X judges with total experience Y. The result for a particular game. GCD of all indicators is equal to 1. If we play with X judges with total experience Y, you'll spend X times Y seconds. Okay, so we consider the total GCD. We need to kill each prime factor. So we're not going to play that many, right? So GCD can be 10 to the 12. So 2 times 3 times 5 times 7 times 11 times 13 times 17 times 19 times 23 times 31. Really? Up to 10 to the 12th. That's 2 times 10 to the 11th. So we can have 11 prime factors. So we're never going to play more than 11 times. So we're never going to play more than 11 times. We gotta do some pruning, right? So we're only going to play at most 11 judges. So somehow we have to do some pruning, right? Indicator of uncertainty about your entrance to the professional layer. This be strange. This is okay. Drink a glass of water. I am drinking stuff, yeah. Move on from this. We haven't really tried this yet. Move on from what? There are two numbers in the first line, N and K. Play one game with each judge. By any natural divisor of AI, which is at most K. Play at most one game with each judge. As a result of a particular game, you can divide the uncertainty of ith judge by any natural divisor of AI, which is at most K. derangements, the professional layer, and number EI. Divide the uncertainty of I judged by any natural divisor AI, which is at most k. GCD of all indicators is equal to 1. X judges with total experience y. You'll spend X times Y seconds. So we can't do something for each judge. That part's true. And we have to kill each prime factor. So we look at the cost to kill you. What is 2 to the 11th? It's like we cannot do this for each judge. Right? What can we do? 2 to the 11th, right, is big. But it's like, it's... How big is 3 to the 11th? That's kind of big, yeah. See, what I'm thinking we do is... for each mask, like what if this is the minimum for all masks except one? Right. Yeah. For a mask of size 5, for example, we only need, we know we're going to take at most 6 others to do this. So we only need the top 7. For a mask of size X, we only need the top 11 minus X plus 1. 12 minus X. Minus X. Which means for most masks, we're gonna have like 7. So it's gonna be like 6.5 times 2 to the 11th. How big is 2 to the 11th? Okay, so we have like, we keep like 12,000 guys. Is it really 11? Let's check that again. Right. So 2 times 3 times 5 times 7 times 11 times 13 times 17 times 19 times 23 times 29 times 31. That is 11 factors. That is 11 factors. And how does this work? Can we really spend 2 to the 11 per guy? Can we really? If you really do have 2 to the 11th, then if we really have that many factors, we only need to keep at most 11 of each distinct pair. Okay, there are some some dumb things we can do, right? We only need to keep at most 11 of each pair. Okay, so that actually makes life a lot easier, because then we could do some stuff. We only need to keep almost 11 of each pair, of each distinct, pair. Well, no, we only, okay, sure. Okay, yeah, so we can do that. That's fine. Can we do 1e6 map ops? How fast is that? Yeah, we can. Alright, so we prune you. Then, for each thing, there's 3. So I mean, even if we have like 2 to the 10th, right? How big are you? 2 times 3 over 31. Right, then you only have like 3,000 leeway. No, you only have like, no, less than that. You only have like 1,000 leeway. Which means that we're not going to keep that many of you. So we're keeping 12,000. Right. I guess this is fine. Okay, so, C into N to K, L of G is 0, 4 L I is 0, I less than I plus plus. C into AI, G is GCD, G, AI. At sort. What are we doing? Number 3, right. F is equal to factors G, get unique F. Gem primes 1e6, VL F is factors G, get unique F. What's up, Sophie? Again. we are going again for the second time today. Right. for li0 is an s, take dot push back XVI. Okay, now let's do VIX. S minus P plus 1. Okay. Okay, so for auto CX, take get cost X. Wait, shoot. That's not gonna work. Oh wait, no, this is fine. PC. Okay. If take two PC I plus 1, take 2 dot size, take 2 I dot size is less than T, and cost I is less than or equal to K. Take 2 I dot push back P. Take 2 I dot size is less than T, and cost I is less than or equal to K. Take 2 I dot push back T. cost x, I is 0 up to 2 to the s, t is s minus pci plus 1. Okay. 4 I 0, I is less than s, I plus plus. Cost 0 is 1. 2 to the I is 1. While x mod fi is equal to 0. Cost okay. Yes. Good. Okay. Take 2I dot size. Less than t, and cost I is less than or equal to k. Take 2I dot pushback p. Okay. Via toad. Okay, now take p, get cost x. Okay. Vector VL sub m. Sub m if cost t is less than or equal to k. NDP NDP I plus 1 m or t is equal to min ndp I plus 1 m or t. Yeah. dpim plus c. Then we do this. Okay, now ants is min ants if dp I to the s minus 1 I times dpi to the s. Okay. No multitests. Four. Okay. Let's read everything. C into n to k, L of g is 0. For I is 0 up to n, C into ai, g is gcd gai. Gem primes 1.186, f is factors g, get unique f, s is f dot size. For I is 0 up to n, C into ci, at ai dot pushback ci. So we're reading in this thing cost. Yeah. At ai dot pushback ci. Vector p I'll take. For auto x v at start v dot begin v dot end. Well, s is min l of v dot size s. For I is 0 up to s, I plus plus, take dot pushback vi x. Yeah. Sorry, take dot begin, take dot end. Vector v I'll take 2 to the s. v I'll pc 2 to the s. Yes. For auto cs take, get cost x. I is 1 up to 2 to the s. If take 2 I dot size is less than t and cost I is less than or equal to k, take 2 I dot pushback p. VL tote, get unique tote. If I and j is 0, sum I dot pushback j. I'm said dp1 size of dp. dp0 0 is 0. For LOP tote, auto cx is take p. Get cost x. I is 0 up to s, and dpim is dpim. T sub mm, if cost t is less than or equal to k, plus 1 mrt is min, and dpi plus 1 mrt. Okay. I is 0, I less than or equal to s, I plus plus. dpi all things less than 1e14. Okay. Alright. Cost 2 to the I is 1. Well, x mod fi is 0. Okay, so PRF tote take. Let's start with this. 430, 530, 130. So F is 235. Okay. this, right? I is 0, cost I is 1. For I is 1 up to S, cost for I is 1 up to S, for j is 0 up to 2 to the I minus 1. Cost j times cost 2 to the I. What? Why? I is 3. For I is 1. For j is 0. Should it be up to 2? It should be up to 2 to the I. Yes. Okay. F is 7, totus bracket, take is 1, 7. Yeah. Okay. Very sus. Very, very sus. I don't know, man. We'll try it, I guess. Let's try custom invocation. Right. So 2 times 3. Yeah. We need this number. We're sorting, right? Sort v dot begin, v dot end. Yeah. How fast do you? Okay, good. Yeah. That's fine, I believe. I have some faith. I have a small amount of faith, I suppose. In Q. You're gonna be like that for a while? You're gonna be like that for a while, aren't you? You serious? Status. Seriously? Bro, come on. Okay, good. All of them are running. That's good. Alright, don't fail. This might have a time issue, won't it? Are you bro? Codeforces. Codeforces, come on. Okay. Yeah, but that's a sample. Come on. Okay, you passed the first non-sample. That's good. Cool. All right. Optimization's worked. Cool problem, I guess. Weird problem, but whatever. I feel like, I don't know, that was kind of sus. That was really sus. I kind of didn't believe that would pass, but whatever. So 1,039,000, right? Oh, actually, they didn't have a... Huh. Did they have a test that would break mine? I don't think they did. No, they had these like highly... If this number was bigger, my solution might have failed. Yeah, if this number was bigger, my solution would have failed, I think. Whatever. We are fine in that sense. It took... Very sus, right? Very sus. I mean, okay, there's like a... There's a large overhead for like... The big, the log factor. If we have like a lot of distinct numbers, if we have like a big map, right? Yeah, if we have a big map, then, okay. So it might have actually not been that bad. Might have not been that bad. I think it probably would have been fine. Could have been bad, but it wasn't. 3,100, huh? That's not bad. That's not bad at all. It's like this didn't get many solves. The people who... Oh my god, 3,000 points. That's crazy. So if you solve it, you just like win life. Wrong answer. Are there any TLEs? I mean, like, it's so yeah, time limit exceeded on test 19. Time limit exceeded, right? What is test 19? 1 million. How did I do on that test? Test 19. Okay, that was fine. Wait, why did we do so fine on that test? Oh, it's because, okay, it's because most of the numbers are the same. Yeah, okay, so this uses that. But we did fine on that because we have our stupid heuristics. Awesome. Let's go. Let's go heuristics. Putting a bound on the theoretical worst case of that is hard. Is very hard. But whatever, it's fine. It's like it's not 3 to the 11th. Worst case could be 3 to the 10th. Like it could be 3 to the 10th times what? 10,000 times 10, which would actually fail. Like, so like theoretically worst case this does fail, but oh, whatever, it's fine. When am I doing a contest? Not soon. I want to get better before I start subjecting myself to contests, because it's not going to be fun once I do start doing them. I'm not going to have a good time, so I want to be LGM level before I do. Stuff. Okay, cool. I guess we're fine. I don't know. We could have... Yeah, it was fine. It could have gone much worse. We could have had a much worse time with this problem, but we didn't, which is cool. But if the tests were stronger, then the difficulty would probably be higher, so... whatever, then. So what took the worst for us? Yeah, but if this number was higher, we would have had a worse time. We would have saved so many more numbers. So it seems like a game of pruning, right? Where you prune as much as you can. Why doesn't it have a number theory tag? Why does it not have a number theory tag? Okay, cool. That's pretty much it for that, right? Because we can't, yeah, we're not solving E. Okay, sure. 530. Huh. 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 This looks fun. This looks fun. Let's read it. Fedya loves problems involving data structures, especially ones about giving queries on subsegments. Fedya had a nice array, A1 to N, and a beautiful data structure. Could find the greatest integer D, such that D divides... Oh, God. Okay. How hard is D? D is like 2800. Fine, we'll look at E. Fedya loves problems involving data structures. So Fedya had a nice array, A1 to N, and a beautiful data structure. This data structure, given L and R, could find the greatest integer D, such that D divides each of AL to AR. Could find the greatest integer D, such that D divides each of AL to AR. So we could actually, okay. This looks fun. Oh my God, this looks so fun. This looks so fun. So fun, dude. This looks so fun. God. Okay, so Fedya loves problems involving data structures. Okay, so you find the GCD of all subarrays. Fedya had a nice array, A1 to AN, beautiful data structure. This data structure, given L and R, could find the greatest integer D, such that D divides each of AL to AR. So we find the GCD of all the things. So that part's fine. We can do that in log squared. That's fine. So we applied it to every non-empty contiguous subarray of array A, put all answers into the array, and sorted it. Call this array B. It's easy to see. So we can find the count. So we can represent B. To that, Fedya implemented another cool data structure that allowed him to find sum BL plus BR for given L and R. Surely, Fedya applied this data structure to every contiguous subarray of array B, called the result C, and sorted it. Help Fedya find the lower median of array C. Recall that for a sorted array of length k, the lower median is an element at position k plus 1 over 2 if elements of the array are enumerated starting from 1. Example, the lower median of array 1, 1, 2, 3, 6 is 2, and the lower median of 0, 17, 23, 96 is 17. So five e4 squared over 2. Okay, that's fine. Yeah, 1e5. Wait, what? Wait, 5e4. So it's 1e5 to the 4th, 1e20. Except it's over 2 to the 4th, over 2 to the 6th, over 2 to the 7th. So this is 2 to the 20 over 10 to the 20 over 2 to the 7th. Yeah, okay. That's fine. This is fine. I love life, man. Having such a good time. So we do the GCD part, and that's not hard, I guess. And then we need the binary search on the thing. We need to do the floor sum, right? And then while you start in here, and you end in here, now this can be big. So the count is less than or equal to this, and go up 1. think this through. So the first step is easy. That's fine. We can do that. Think of it this way, then we subtract 10. I see where Fedya the Potter Strikes Back comes from now. And it's another annoying as hell problem. It's another 3,400. Allow him to find some BL plus BR for given LNR. I mean, this could be on the order of n cubed, which is like fine, but it's like we have a size n squared. You're into expert in 9 months. No, I mean, slow is relative. That's faster than most people. Most people don't even make it to expert. It depends on what you're comparing to. If you're comparing to LGMs, maybe. If you're comparing to reds, it's probably fine. Let me erase. Sort array of length k. The lower median is an element at position k plus 1 over 2 if elements of the array are enumerated starting from 1. How do we do this? I'm actually not sure how to do this, because we need to... So we have like this counter 10. Let's move you up to 7. When this counter gets below 0, we need a new one. So this counter is 16. -1, 0. And this counter gets below 0. So this is echoed floor sum. This is where this comes in handy. This is where this comes in handy. But echoed library didn't exist at the time of this contest, so we're not going to use it, I suppose. Do we have to solve this specific problem though? I mean, we kind of do it, right? Like, yeah, we're solving this specific problem. You're going to period up to the GCD of this, which, like, it's 4:30 p.m. Well, I mean, US spans 4 time zones, so it's from 1:30 to 1 to 4:30, depending on where you are. Okay. How? How? ax plus b mod ax plus b over c. Ax plus b over c. So sum I equals 0 to n minus 1 of ax plus ai plus b over n. Right, so that's ai plus b mod c. So how do I do ai plus b mod c? So we're given here that A is strictly less than C. Okay, we can do this with a meet in the middle, but it'd be insane. That would not work. That would be n. That would be a big constant. It would be like n root n log squared. That's not going to work. So here, like 3 and then 10, for example. Yeah, what does this do? Like, what do we do with this? Encoder has some weird like transformation, right? Like you reduce it up to log n times, and then what? This does not seem fun to implement. AI plus B over C. So we have this periodic sequence, right? Empty's periodic in the LCM, that's fine. So we have B plus A, B plus 2A, etc. So I suppose you're like 7, right? 7 and 15, which have GCD 1. You're going to go up by 7 each time. I can't bring myself to derive this, man. Like, God. I understand in theory how you could do this, but whatever. So, screw it. Screw it. I don't want to do this. That's wild. That's wild. Okay. How far away to make a sum J related contribution? Sum J equals 0. So you solve for I. Holy Christ. Interesting. This is very interesting. Above summation. Cool story, bro. Cool story. God. Okay. Yeah. Sure. I'm not gonna solve this. We're not gonna solve this problem. I mean, okay, yeah. I don't know. That's the hardest subpart of this, and God. Okay. I mean, it's well known now, which is fine, I guess, but that's kind of crazy. I don't want to code this. Screw it. This is not worth coding, but sure. I mean, I can see it. You screw with the sums until you find a smaller problem that somehow exists, and yeah. Interesting. Interesting. Sum. Okay, solving for I is actually genius. That's crazy. That's actually crazy. Nice. That's yeah, that's cool. That's cool. That's interesting. Alright, whatever. I need to. Okay. Well, do we call that solved? I mean, it's not really solved. I didn't really solve it. We'll call it solved because the code exists now, but like I don't really want to, like if we got this problem in a contest, like we'd plug in the coder thing and it would work. So we could call it solved, I guess. I don't know. It's kind of weird. That's fun. So transformation of sums. I need to think about that technique now. That could definitely be useful. Transformation of sums. So you turn it into an inequality, a sum over an inequality. You solve for I, you move the inequality around, and then you, holy crap. That's crazy. That's actually crazy. That's smart. That's smart, man. I'll give him props for that. It's kind of solved. I mean, like I said, if we got this problem in a contest, we could plug in the coder thing. The coder thing didn't exist at this time. I feel like, does that blog exist for this problem? Like, where does this problem come from? In a winter camp. Okay. Floor sum. Like, what the hell? Why do they have this? Like, this is so specific. And I'm glad they have it, because it solves the problem I need, but... It's so specific. It's so specific. It's like a weird thing to have in a generic library. AI plus B. And to calculate the sum of mod, that's easy. From this. Interesting. Very interesting. Very interesting indeed. Interesting task. Right? It is interesting, right? Like we need to think about that again. We need to internalize this technique, I suppose. That you swap. That's crazy. That's actually crazy. Okay. 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 Sure. Yeah. Sure. Cool, man. Cool story. And that solves this. You're 3,400, right? Yeah. Okay. We'll call it mind solved. All right. I want to do my virtual because it's about time for that. It do be about time. LO's long. Okay, where were we? This one works. This one was the one we just did, right? Yeah. Okay. Yes. Okay, sure. All right, I'll be right back and we'll start this. Okay. Here we are. So we have stuff. Let's get started. Okay. Why? Seriously? Let's ask us to find 3 numbers in this array. C into N. VLA. C into X, VX mod 2 dot push. So either 3 odd numbers, you have either 3 odd or 1 even 2 odd. So if v0 dot size yes, else if v1 dot size is greater than 1, v0 dot size v What the hell is this problem? Why'd you ask this? What? What am I missing? Yeah, there are yes, yes, no, yes, no, yes. Okay. So there are 3 odd or 1 odd, 2 even. That's it. So v1 dot size greater equal to 3, v1 0, v0 0, v0 1. Yes. Okay. Sure. Dumb problem. That's a good start. Select an integer k. Select an integer k. Split the array into k subsegments. Calculate the sum in each of k subsegments and write these sums to another array B. Where the sum of the subsegment LR. Okay, I mean, it's always going to be 2, right? Because suppose it's more than 2, then suppose you split into more than 2. Merge the 2 together. For any divisor, if it doesn't divide this, it might divide this. If it doesn't divide this, it definitely won't divide in one of these. And if it does divide this, then yeah, okay, sure. Okay. VLAN. 415 through 121. C into n, V L A N, S is 0, C into x, S plus equals x. Plus 1 is less than n, I plus plus, S plus. Yeah. Okay. Sure. We have, oh, it's long. Really strange. Okay. I guess it's a div too. Wait, was C? Oh. Oh, this was that round. Oh, this was that round. Can I start another virtual? Wait, hang on. I didn't realize this was that round. This was the round with the NP. Okay. Can I start another virtual? Damn. Okay. I didn't think that through. I didn't realize the problem didn't have a B. Can we start another virtual? Can I? Will it let me? Will it let me? Will it actually let me? Nice. Okay, cool. All right, so we're just gonna pretend that didn't happen because this was the round where the C was NP hard, and and they they only realized that mid contest. So we're not gonna continue that round. We're just gonna pretend that didn't happen. I'll explain B after this one. Remind me after. Or, I mean, B is basically it's always gonna be, you're always gonna split into at most 2. You can do some casework and prove that if you split into more than 2, merge 2 of them together, the answer can't get worse. Proving that is caseworking on what divides, what doesn't. Like, you can't gain any divisors from splitting. So, okay, we're just gonna start anew. This one does have all of its problems, so that's fine. Array A is good if for all pairs of adjacent elements, AI and AI plus 1 are of different parity. Sure. Okay. C into N, B L A N for LO. If AI what? Oh wait, yeah. Okay. C into N, V L A N for LLXA, C into X, I plus 1, yeah. Sure. Okay. Alright. Permutation of length N is an array. 2, 3, 1, 5, 4 is a permutation, but 1, 2, 2 is not. Okay, sure, yeah. Create an array, P concatenated with its reverse. Task is to find the sum of beauties of all n factorial permutations of size n. You're trying to trick me. C into N. S is 1. N times N minus 1 mod. Yeah. Okay. C into N, S is 1, S is S times I mod. Sure. Be that way. All right, the school sets aside on its team for an international quiz. There are N students in the school. We can describe the students. We should be fast on that, right? Yeah, we're fast on B. That's good. Good stuff. N students in the school. We can describe the students using an array A, where AI is the smartness of the I student. There are M topics. AI mod T is 0. Find a team that is collectively proficient in all the topics such that the for every topic, such that the maximum difference between the smartness of any two students in that team is minimized. Find a team that is collectively proficient in all the topics. If for every topic, there's a member of the team proficient in this topic. The maximum difference between, okay. C and N to M, divs. R 0. BLAN for LXA, C into X. While R is less than N, what are we doing? For L is 0 up to N, L plus plus, while R is less than N, and T is less than M. For LX divs AR, if count X plus plus is equal to 0, plus plus T, plus plus R. If T is equal to M, ants is equal to min, ants. Yeah, so let's make sure that works. So max is up to 10 to the 5th, which means it's going to be 240n. Yeah, C and N to M, VL count M plus 1, LT is 0. Sort, and it says 189, R is 0. L is 0 up to N, while R is less than N and T is less than M for LX divs AR. Do that. That's why we check. That's why we check. For LX divs AR, if X is less than or equal to M, if count X plus plus is 0, plus plus T, plus plus R. If T is M, ants is min, ants AR minus 1 minus AL. Yeah. Cool. given a tree of n nodes rooted at 1. Every node has a value of either 0 or 1 at time t equals 0. Okay, we're doing not bad. Pretty good, pretty good. You're given a tree of n nodes rooted at 1. Every node has a value of either 0 or 1 at time t equals 0. Huh? Bitwise XOR the values of its children at time t minus 1. For all 2 to the n initial configurations of 0s and 1s in the tree. Cool. Cool. Okay, so how many are you? How many are you? So at time 0, at time 0, you're going to be this. 2 to the 1 minus 1. At time 1, you're going to be 2 to the number of children you have minus 1. At time 2, you're going to be 2 to the number of children you have minus 1. We can't exactly product you, right? Do they want us to small to large? What do they want us to do? Oh wait, no, it's oh, okay. It's depth. Okay, yes. Okay, sure. EL edge 200,005 S is 0. DFS. We need mod up. No, we don't. R is max R. And it's plus equals R minus D plus 1. Yes. C into n for I 0 up to ni plus plus, agi dot clear. C into x to y, yes. F is 1, f is f times 2 mod mod, ants is 0. Ants mod equals mod. That can overflow. Ants is 0, dfs 0, negative 1, 0. Ants times equals mod. Print ants times f mod mod. Yeah. All r is d, all x ag v. Yeah, sure. I believe. Edge reverse. You'll be given a weighted directed graph of n nodes and m directed edges. The ith node has a weight of wi. Solve on f, but not really. Noemi is doing very well. Who has that solve on f? Okay, whatever. You're given a weighted directed graph of n nodes and m directed edges, where the ith node has a weight. We'll pay attention to both e and f. The ith node has a weight of wi. You need to reverse some edges of this graph such that there is at least one node in the graph from which every other node is reachable. Maximum weight of all reversed edges. Okay, so maximum weight of all reversed edges. So that there is at least one node in the graph from which every other node is reachable. Find the minimum cost required for completing the task. If there is no solution, print a single integer -1. Given a weighted directed graph. So I mean, okay. So we can assume it's a DAG. Ignore everything and group everything together in SCCs. Assume it's a DAG. If the graph is not connected, it's -1. Obviously. The graph is connected. Then what do we do? What do we do? So we don't need, there's at least one node in the graph from which every other node is reachable. So we look at each top guy. They say F as a solve. Okay, solved E. Jesus Christ, by the way. You're given a weighted directed graph of n nodes and m directed edges, where the ith edge is a weight of wi. To reverse some edges of this graph, there's at least one node in the graph from which every other node is reachable. Is equal to the maximum weight of all reversed edges. Okay, binary search, right? Oh. All right, so we binary search, we run the SCC algorithm a bunch of times. We can assume you're undirected, right? Because if we read, yeah, this is fine. Okay, we can do this. And M. Okay, so SCC. Man, I cannot catch up to this guy. This guy's crazy. Vector array L3EL. For Li0, I less than M. L is 0, R is 3E9. What's my syntax? For auto X, Y, Z, EL, Z is less than or equal to M. SC.edge XY. YX. Auto C is equal to SC.run. SCX not equal to SCY. What am I doing? Lab. If T is 1, alright, this might TLE, but hopefully not. C into N to M, vector array L3EL, for I 0 up to M, C into XYZ, minus X, minus Y, L 0, R is 3, 9, L is less than R, C dot N. C is less equal to M, SC dot edge YX. Auto C is SC dot run. Lab N count N. LS is C dot size. So for I 0 up to S, for LX CI, lab X is I. So for auto XYZEL, if you're not in the same component, add 1 to the count of this. Does this actually work? Well, T is 0. For I is 0, I is less than N, S, I plus plus, T plus equals count I is 0. Well, yes, because if lab, if you're a good edge, yeah, that's fine. T is 0. T plus equals count I is 0. Yeah, this is fine. Okay. If you're a small edge, then we'll just ignore you. If you're a small edge, then lab will be equal, so it doesn't matter. Okay, sure. Alright, comfortably num. Given array A. Dump TLE. Damn. Okay. Seriously? Seriously, man? Okay. We're given a weighted directed graph of M nodes and M directed edges, where the ith edge has a weight of Wi. For I is 0, I is less than edges v dot size, I plus plus. If not used, edges vi, dfs1, edges vi. Fine. VL toke. What? R is toke dot size minus 1. 3, negative 1, 25. Wait, why are you 0? Oh, toke dot pushback. Okay, sure. Is this good enough? Oh, 0. I mean, SC is working in ints. Let's try it. Why do I have to constant op so much, man? I mean, it's freaking linear rhythmic. Okay, good. Thank you. Okay, so we're doing well. We're doing quite well. Okay, F is left. You're given an array A consisting of n non-negative integers. The numbness of a subarray, AL to AR, for arbitrary L less than or equal to R, is defined as the max XOR the XOR. So everything without its max. Numbness of a subarray. So it's everything without its max. The numbness of a subarray is defined as max XOR the XOR. Fireworks? Really? Okay, cool. Given an array A consisting of n non-negative integers, the numbness of a subarray is defined as the max XOR the XOR. So it's close to max subarray XOR, except you're missing the max. So I mean, fix an ordering, right? Fix an ordering. Say that are you serious? Are you actually wait. This is really what you want. You want me to write a are you kidding me? Oh my god. Bro, why? Okay. God, dude. Okay. So you want me to write a segment tree of tries? Are you serious? 8-second time limit. N log squared. Are you serious, dude? Wait, no, it's worse than n log squared. Wait, okay, that's n log cubed. Okay, that can't work. Hang on. That can't work. Can that work? That can't work, right? There's no way that can work. That can't work. That can't work. That cannot work. Can it work? What's your constant? Are you serious, dude? That can't work. Does it need to work? Wait. No, it doesn't need to work. Because we can do DSU, can't we? Wait up. So yeah, we can do DSU. We can do DSU. Okay, so that's going to be log squared, and that'll be fine. It's really sad that the test cases they gave us are like this. We're probably going to write a stress test for this. Okay, so C and N. So we condition on all subarrays including this max. We condition on all subarrays including this max, which means we can ignore this. We condition on all subarrays including this max, which means that, so you include this max, then you can be anything here. Okay. So I see why this has no solves yet. Rxr equals AI. We don't need del. Okay, you're up to 10 to the 9th, that's fine. Struct try VL at node root vector try tr so you can actually all go up there. DSU, DPF, DSF, DPF dot N, DSF, DPF dot try dot TRI dot add dot push back PFI. DPF dot TRI dot root is equal to new node. DSF, DSF, SF. Okay, now we build RMQ because seg tree. Where were we? Templates. Seg tree. No, we need better. We need old templates. I still have not written this. Still have not written this better. That's fine. Okay, so seg tree min t st dot na rec 0 and -1. rec L. If L is our return. M is equal to st.query lr.end. L is greater than or equal to R return. Rec L m minus 1, rec m plus 1 R. Okay, now if R minus M, so if M minus L is less than R minus M, then do left. Marks M plus 1. Okay, what do we need? So DSU, DPF, DSF. Seg tree min t st allow answer 0. So if we're doing this, if we're doing L, then we need DPF. Okay. A M. For L I is M, I is greater than or equal to L, I minus minus. X XOR equals AI. Ants is max. Ants is max, ants X. So we try 0. Ants is max, ants DPF dot try. No. What are you? So you're best. DPF dot try dot trt dot root. X XOR PFM. This is max ants best dpf.trt.root x XOR PFM. PFM dpf.trt.root x XOR PFM. Okay. Else assert t is dsf dot marks m minus 1. Best dsf dot trt dot root x XOR SFM. That should be easier. Okay, now if L is less than or equal to n minus 1, dpf.merge n minus 1m, dsf.merge n minus 1m. Okay, now for lx tr marks a dot add tr marks b dot add dot push back ints tr marks b dot root x. Okay. Stupidest problem of my life, but what? Vector try tr. Why do you not work? What? Node targ. Unused parameter targ. A global scope. Template argument. You want me to? Are you serious? Bro. No, it doesn't. Why does this not work? Why do you not compile? Oh, fine. Is that why? No. Okay. Cool. Awesome. This is min. We want max. Targ done next, not v. That. What? How? Wait, how though? In ants is 0. For I is 29. I is greater than or equal to 0. Minus minus I. Not. X and 2 to the I. Why does that make you infinity? Int v is not x and 2 to the okay, whatever. If run. And it's 0. L is 0, L is less than n, L plus plus, L x is 0, m is 0. For L r is L, r is less than n, r plus plus. 2817. Answer 0, curve 17. Okay, cool. Great. Okay, so (2817). Why? So m minus l is less than r minus m. This is max ants x. PR so you fail at n equals 2. N equals 0. Curves 12. Okay, answer 0, curves 1. So dpf.trt.at is 0. L is 0, R is 1, M is 0. How does this work? dpf.trt.at. Push back. Oh, because we didn't insert anywhere. dpf.tri.root. Inst dsf.tri.root. Okay. Answer is 29, curve is 28. What the hell? Why does that work? L is 0, R is 2. M is 2, dsf.trt.at is equal to 1023. L is 0, R is 2, M is 2. XR. L is 0, R is 2. I'm doing min, not max. Holy crap, this code. Turn val is less than, yeah. Okay, bus error. That's cool. What do you mean bus error? What? Oh, wait. Stop. Excuse me? How? L is greater than or equal to R return. LM is st.query lr.ind. Rec L m minus 1. st.init na. So I mean that's all fine. M is st.query lr.ind. Rec L m minus 1. Rec m plus 1 r. Okay. Alright, we need to comp our L is 1, R is 2, M is 2. Why? What in the world? Template type name numt struct segtree int n depth vector numt tree lazy. What in the world? Three 29 310. How? AI is RNG mod 2 to the 5th. If run C into AI. That's okay. That's all okay. What? Oh, that's why. Because I'm being dumb. Okay, sure. Sure. Beautiful. Okay. Now we test you on custom. Okay, see how fast you run, I guess. Memory limit exceeded. Shoot. Okay, that's concerning. How much memory do you use? Like here, right? Okay. Destroy. CSF. Dot root. Void destroy. I cannot type. What in the world? N is 200,000. Oh, okay. Okay. Wait, no, wait. 0. Okay, sure. Wait, no, wait. Yeah, this is fine, actually. Sure. Using LO is equal to int 5553, right? Hey. Okay, it doesn't matter. Let's get rid of the pragma. And we can use fast try if we really need to, but I don't really want to. Okay, that makes life slightly better, I guess. Do we do it? Do we submit? Screw it. Let's do it. You might TLE. You're probably going to TLE, but we'll see. Nice. Okay. Cool. Cool beans. Alright, that was slow apparently. Maspy got destroyed. Holy crap. Wait, what? Wait, no, sorry, Noemi. Noemi won. Never mind. I got confused. Okay. Yeah, sure. So we probably beat Neil. I don't know if we beat this guy. We might not have. Let's see. Oh, damn. Okay, I guess we didn't. Wait, why did that happen? You're slow on F, I guess. If we were faster on F, which I guess everyone else was, then we would have done fine. What happened? Yeah, it was really, really tight here. Like 100-point difference would do that. And then Noemi dominated, of course. So actually that penalty would have... That penalty would have probably sent me up here. Ugh, that's dumb. That's a dumb penalty to have. I mean, SCC is slow, sure, but yeah, whatever. It's like what happened here was that, damn, how do people get F so quickly? There's probably a better way to do it, I guess. It's probably a better way to do it. How would you do that? And if you keep a stack of maxes, that wouldn't really work because you have a lot of maxes per. If you relabel, that wouldn't work. If you do things like that, it wouldn't work. If you, we can divide and conquer. We can do the min thing, min LR. We could do DSU with tries. This whole thing is so dumb. And then we do DSU with tries, and then that whole thing works, I suppose. It's n log AI, sure. Damn, man. We were just faster on F. Faster on F. Everything else went fine. It's just F that hurt. That's a shame. Cause like, I mean, it wasn't that hard code to write. You just have to get it right, I guess. X equals AR, M is max. Still, that was surprising that it took 40 minutes, actually. I guess it shouldn't have taken 40 minutes, probably. Given the speed of everything else. Okay, cool. Alright, so we got 7th. That's not bad. Not the best. Doesn't beat yesterday, but it's not bad. Best way to learn programming language. Use it, I suppose. Find a project you enjoy and use it. Get comfortable with it like that. Like a bunch of other people solved that in what, like 20 minutes, 10 minutes? $20. That's kind of crazy. Took me 36. I don't know how that works. Guess you could just be fast. What are the other problems? C was that thing, right? Just kind of do it. And then this one was, we were fast on this one. It was a second to solve it. It's like fine. Okay. It's strange that I've had like no test cases. It's easy to stress test them, so it doesn't hurt. So like that's the power of stress testing. Like it takes half a minute to set up brute force, and then you just run it, and then you get infinite test cases. It's very nice. Okay. All right, this one. So G is interesting, I suppose. And E seems impossible, which is good. I like impossible. I'm going to treat T as n vertices number from 1 to n. Oh, wait, I've seen this problem. Okay, never mind. Right. Okay, that's a shame. Yeah, I've seen this one already. The trick is to So we need the number of edge subsets of size k. Yeah, I've already seen this. I don't want to resolve it. It's kind of lame. I've seen like, okay. No, it's fine. Yeah. I've kind of seen some ideas from this too. I don't want to touch it. Okay, so G's hard. G I know. I don't know how to do it. We'll look at H. What? Okay. That's strange. What? Okay, so we have an unordered pair, a list of unordered pairs. That's what's happening here, right? So we can decrease the distance to the left. Choose a single blue token and moves a K cells to the right, or both. Okay, so we have an unordered pair of numbers. So I mean, all primes work, which is fine. 21, 23, 25, 27. No. What is going on? Bob selects a single red token. Right. So I mean, if it's symmetric, the Grundy is always 0. Right, that's always true. If what do we condition on? I mean, there are a lot of primes. So what's that mean? Game theory, strange game theory. Something is happening. Red token is to the right of the white token. The red token is to the right of the white token. 19. Okay. K must not be equal to the previously picked integer f. So I mean, wait, what am I doing? Wait, what am I doing? Wait. Bro, I'm crazy. They're independent games. I'm crazy. I'm actually crazy. Okay. Well, that makes life a lot easier. They're independent games. Okay, yes. I was thinking about how to solve nim with two piles, and it's like, yeah, they're independent. That's how that works. Right. Okay, so we have 2 times 10 to the 5th games of nim. We need to find the Grundy numbers, right? So that's the tricky part. We need to find the Grundy numbers. Can we just do it? Like, okay, hang on. Can we just do it? Like, can we just do it? Like, can we just do it? C and end f. X. Const L max equal to 2, 5 plus 3. Gr max. Okay. So we use number theory. Gem primes 24. BO move. For I is 2, I is less than or equal to max. If I is not equal to x, factors I. If f dot size is less than or equal to 2, move dot pushback I. PR move dot size. Damn it. Okay, we don't. We'll keep that. Keep the pragma. Oh. Oh, that's a lot. That's a lot. That's a lot. Yeah, that's a lot. It's like almost all of them, right? It's almost all of them. Which means like... Are you serious? How are you so many? Yeah, that's a lot of numbers. That is a lot of numbers. Well, that's a shame. So if you're just primes, then you'd be fine. But you're not just primes. For MV, for LX MV, if x is less than or equal to I, TS I minus GR I minus X is equal to I. While TSP is equal to I plus P. GRI is equal to P. You're small. Interesting. I have multi-tests on. You're small. Why are you so small? Are you repetitive? You can't be repetitive, right? Are you serious? No, okay. No, okay. So I mean, what, right? What? How fast are you? If we could just see. We could just see how fast this is. L equals int. And we do the pragmas. How fast is this? Damn, really? Oh my god. J. TSGR I minus MBJ is equal to I. So something's going on. Something is going on. Oh, I is 0, I is less than max, I plus plus. Damn. They timed this. 205. Let's make that smaller, right? Doesn't make it any faster. I is 0, I is less than max, I plus plus. They timed this. They definitely timed this. So how do we be smart about this? Okay. Count. Plus plus count. No, that doesn't really work. is max B GRI. How big do you get? 26. $34. What? Oh, okay, let's just stop it. B is max B GRI. Okay, interesting. Yeah. Claiming the numbers in the middle don't matter. We'll see. TS GRI minus X is 1. P is 0, well TSP is I plus P. Return P. Why is that so much slower? Oh, that's why. Cool. Cool. I guess this works. GR is Q. Okay, Lx is 0. For Li is 0, I is less than n, I plus plus. C. X, if x is not equal to 0, cool. What? Wait. What have I messed up? Huh? Min I. Why? What in the world? I is 2. For LLX, wait. Do you work? What in the world? What am I messing up? Oh my god. That explains a lot. Okay. Right. Damn. Okay. 7. Damn. That's a lot more. P is 18, Q is 11. Yeah, and Q's always going to underestimate. G plus plus, T minus minus. Okay, sure. Now let's Bob. Damn. Holy Christ. So we could be asked about every game. They could, in theory, ask us about every game. Damn. Wait, what? You worked before. Now, what is this code here? Oh, wait, you work for 6. Right. Where are we missing you? Bro. Okay, this is stupid. Let's do better. We can do better. We can do better than this. We can do better than this, man. This is really dumb. Yeah, it's just strictly slower. Okay. VL at. Bool tr max plus 5. 4lx mb trx is 1. Okay. fi. Okay, we're scrapping f2. 4lj0 j 100. We'll pause 0. At q.push back I. Okay. How fast are you? Oh, lovely. Okay. Cool. Sure. So we are abusing the fact that the Grundy numbers are small. That is not something I've done before, but that's interesting. Nice. All right, I'll take it. 3,200, not bad. Yeah, that's not bad at all. Just hope that either there, okay, actually, yeah, because the fact that there are 60,000 transitions And the fact that Grundy numbers are almost random in that sense, that like pretty much either we're going to run out of transitions quickly or we're going to find one that works pretty quickly in either case. So that's fine, I suppose. Cool idea, I guess. Abuse the fact that the Grundy numbers are small. I've never actually seen that before, but I guess that's a thing. There's a thing we can now do. Man, why did I? Okay. It's kind of dumb how I initially thought of this problem. I thought it was pairs of piles, even though the pairs are independent and therefore they don't matter. Whatever. I guess it's fine. I mean, yeah, this runs quick enough. Alice, Bob, Alice, Bob, Alice, Bob, Alice, Bob, Alice, Bob, Alice, Bob, Alice, Alice, Bob. Yeah, it's harder to make a Bob, Alice test, right? Because like Bob, Alice tests are like much stronger because the Grundy has to be exactly 0. So it makes sense for more of the tests to be Bob, Alice. It's a lot of Alice Bob, though. Yeah, we need some more Bob Alice in here. Okay, cool. I mean, yeah, it's the same runtime on every test, too. Alice Bob. There's a chance that screws us up complexity-wise, but it didn't, so that's good. Strange that, okay. They definitely planned out 4 seconds, because Pragma's running like 4.8, which I guess is obviously unintended, and I guess they want you to muck around with the small Grundy numbers instead. Interesting. I've never seen that before. Muck around with small Grundy numbers. Determine who wins for 2 games if Alice starts and if Bob starts. Yeah. 2e5. Okay, so G I'm not going to do because stuff. Yeah, we're not gonna touch G. Damn, he got damn. That's rough, man. He got G and H but not E. That's rough. Got E, gets fast. Good rank. Doesn't beat Tourist, but Tourist is literally a problem's worth of points ahead of second place. That's actually crazy. Same problem solved, but he's a problem's worth of points ahead. Oh, that's wild. That's wild. Cool. Damn, he actually got G. Imagine knowing how to do G. G just seems like, I don't know, it's kind of like seems kind of famous for what it was, but I don't know how to do it. It's using some number theory facts that I don't understand, or don't really know, I guess, but whatever, yeah. Okay, well, H was fine. 2 hours, 40 minutes. Okay, let's keep going. So we haven't looked at this div one. Okay. So E is 2900, F is impossible. Sure. We'll look at E. Petya collects beautiful... What? Matrix of size m by m is beautiful. M by n is beautiful if all elements of the matrix are integers between 1 and n. For every row of the matrix, so every row is a permutation. For every pair of vertically adjacent elements, these elements are different. For every pair of vertically adjacent elements, vertically adjacent. Okay. Vertically adjacent. So we're basically counting derangements, right? We're basically counting derangements. We're basically counting derangements, right? Like, you're basically derangements. 1, 2, 3. Okay, well, that's interesting. So, for some fixed permutation, and we're basically, it's the same as counting derangements. Yeah, it's the same as counting. There's no way it can't be the same as counting derangements. Yeah, like take any permutation. Take any invalid permutation. Shuffle it so that, yeah. Okay. So we're counting derangements for that, which is fine. But then the hard part is we have partially formed permutations. Matrix of size m by n is beautiful if all elements of the matrix are integers between 1 and n. For every row of the matrix, all elements of this row are different. So, we need the number of permutations lexicographically smaller than the current row. And we need the number of permutations lexicographically smaller than the current row. And index of lexicographically smallest matrix is 0. Okay, sure. So the number of beautiful matrices might be huge, but I want you to calculate the rarity of the matrix A modulo 998244353. Okay, so you need to be not n cubed. So that's cool. So we need to use the derangement formula, right? derangements of size 3. There are only 2 beautiful matrices of size 2 by 2. These are the first 5 beautiful matrices of size 3 by 3 in lexicographical order. So we fixed that these elements must be used. We have a partial derangement, right? So we need to generalize derangements. We need to say that k positions are unallowed. So we need a remaining permutation. Except some elements have blocked things and others don't. Let's say the first k elements have blocked, right? So we're counting derangements where the first I elements cannot be equal to I. And the rest of them are fine. Counting derangements where the first I elements cannot be equal to I. First I elements cannot be equal to I. So how does the derangement then work? So if we place you in a cycle of length 2, right, then there are a certain number of ways to do that. There are a certain number of ways to not. And if we place you in a cycle of length greater than 2, right? If we place a 2 here, if we place a 2 here, So f of nk is if we place a 2 here, right? Okay, yeah. Okay, so F 2005. Okay, so F sand n. F10 is 1, F11 is equal to 0. I is 2, I is, let's go to n, I plus plus. 4, LOK, 0, okay, let's go to n. Okay, so mod up. We need 998 mod. Gen factorial n. F I0 is equal to fact I. Cycle of length 2. FIK. So what are you? So your so we have k minus 1. Wait, what are you? Okay. Both. If k is greater than or equal to fik is equal to fik plus. So we have k minus 1 things to choose. K minus 1 times fi minus 2 k minus 2 mod mod. It's like 2, 1. So if we create a cycle of length 2, fik is equal to fik plus so your n minus k, right? N minus k, I minus k times f I minus 2 k minus 1. K is greater than or equal to fik is equal to fik plus k minus 1 times fi minus 2 k minus 2 mod mod. Right. If we place a cycle of length 2 and we get rid of 1, then fik is fik plus I minus k times f of I minus 2 k minus 1 mod mod. So if we create an open cycle, and then we do both, right? Fik is equal to fik plus k minus 1 times fi minus 1 k minus 1 mod mod. Fik is equal to fik plus I minus k times fi minus 1k mod mod. Yeah, right. So if we create an open cycle and we have 1, then we create a new position that's bad. Yeah. Okay. PR. Okay. LO if local C is equal to 0, VLAI. Do while next permutation. What? What? I is 2, K is 1. What? What? I is 2, K is 1. You should be 1, right? So what's wrong with you? FIK is FIK. Oh wait, F00 is 1. Beautiful. Assert C is equal to FIK. Beautiful. Okay. Cool. Now we do the other part, which is to say that okay. Well, C is 0. Okay, we're gonna get rid of this because we don't need this anymore. So you work. Now what we need to do is do something. What we need to do is something, right? You have a 998 mod. Okay, so let's get rid of the pragma. Okay, right, so for the first row, it's special. For the second row, it's not special. Ugh, that's annoying. Okay, so How does this work? So what we need then is a Fenwick for these positions and a Fenwick for satisfied positions. We need two Fenwicks. Okay, so LL smart vector VLV. So we need to Is there a nice formula for this? I think there kind of has to be. It's 24, 18, 14, 11, 9, 120, 96, 720. Well, okay, the first one is obvious. But then it converges to n factorial over e. And that's like, that's not happening. That's not happening. So I don't know what's up with that. N factorial over e. Bro, that formula. Many things still scare me. Many things indeed. We're gonna have to do this. So what we need is two things. A, satisfied positions. We have Fenwick for two things. A, used elements. B, used elements that have been satisfied, right? Elements that were either used or are gone. Elements that were either used or are gone. Okay. Bool have bool open. For L I is 1, I is less than I plus plus. Have bit init dot init n plus 1 plus plus lock bit dot init n I1. Okay. bit ht the net op net. Wait, so so initially, this is really annoying. It's combo and it's data structure, so that's like a scary mix. Okay, fac is equal to mpow fnn. Fac is equal to fac times minv fnn mod mod. Okay, so PV is equal to I is equal to 0, -1, V I minus 1 J. All bad is equal to I is equal to 0, 0, n. Okay, so now LO under is ht dot query v ij minus 1. ot dot query v ij minus 1. have PV minus minus under, right, if have PV minus minus under, if PV is open, oh wait, well if we have PV, then PV is also open. And PV is strictly less than Bij. If have PV minus minus, so if we have 3 here and we have a 2 above and 2 is open, we haven't placed 2 yet, then we miss out on one that does that, and we miss out on one in general. Yeah. Minus minus op. LL BP is under minus op. T is equal to under times F n minus j minus 1 bad. No, it's BP bad plus OP times F n minus j minus 1 bad minus 1 mod mod. Okay, so ht.add Vij negative 1. Have if open Vij minus minus bad, open Vij is equal to 0, ot.add if PV is not equal to negative 1 and open PV minus minus bad. Okay. Negative 1. What in the world? Under. What? How? What in the world? How did I type VTJ? Okay, so 2, 1, right? Wait. So OP. Wait, why? Why is OP 1? I is equal to 0. Okay, yes. Under is 0. Empty. Index. Okay, that makes sense. 2. 6. Great. Okay. PRIs. Under is 0. Have j is 1. If I is not equal to 0, open j is 1. Okay, better. But you're still broken, right? 2, 3, 1, 3, 1, 2. Why are you still broken? Under is 2. So we have 3. So we have exactly 1 that we can put down. This 1 is going to remove one of you. So we're going to put down a 1. Then we have F2, 2. Fac. I mean, you're still wrong, but you're less wrong now, right? Yeah, so bad is 3. So if have PV PV is not equal to -1 and open PV minus next. So this doesn't change anything for here, but it will for the other ones. Okay. Now we need to really check this. Vector VLP if local. for auto x v for VLA P vector VL R is X, R dot push back A, push back R. V is equal to MV. Okay. What? V dot push back. Okay, now if xij is equal to xi plus 1j, if pause and v dot push back x. Okay, now for li0, I is less than v dot size, I plus plus, cert, smart vi, LR is smart vi. Cool. You work. Cool. We have 998 mod. We're going to assume this works. Sure. Nice. Okay. Coolio. That was about as expected. That's pretty much exactly 2900, yeah. Damn. Bro, this guy's struggling. Imagine. Imagine. How do we do? Yeah, Kostya. Of course you solved F, why not? Why not? Is test 5 big? No. Well, yes, but it was the first real test, I guess. Actually, no. Yeah, test 5. It was a large test, I suppose. And they have some very large tests, which don't take that much time. Very nice. Very nice. Okay, so F has one solve, and it's by that guy, whose name I can't pronounce. So we're not going to do that. I'm going to read it, but... Berlin forest was planted several decades ago in a formation of an infinite grid with a single tree in every cell. So dense, actually, that fire became a real danger. Second fire is started. I considered the second zero. Every second fire lit up all intact neighboring trees to every current burning tree. Val x y be oh I see. Grid is infinite. Interesting. Val xy, destructive power is the sum of val xy over all xy of burnt trees. That's interesting. Occupies adjacent by side or by corner cell. Ugh. N is 50. So that seems hard. That seems hard. It seems hard. And everything's 10 to the 8th, which is very large. 10 to the 8th is very big. Modular doesn't matter. That time the fire department extinguished the fire. 10 to the 8th. That's like... It's big enough to compute all of them. We just need to do it in like O of 1, right? And we just need the number of cells. Yeah, we don't need... Okay. Are you actually attempting this? Maybe we are. Maybe we are actually attempting this. And we just need the union of a bunch of squares. It's going to be like a piecewise function almost. Will it? And we need the union of a bunch of squares. We need the union of a bunch of squares. We need the union of a bunch of squares, right? The union of a bunch of squares. What characterizes the union of a bunch of squares? It's going to be some weird piecewise function. 50 is to prevent overflow. Sure. What characterizes the union of a bunch of squares? So we can't do NT. That's not fast enough. But we can do O of t plus n. Or something like that, right? Can we do some sussy things? Can we do some, like... Can we assume that once the shapes are uniform, that they're going to grow at a fixed rate? Can we fix the second derivative? Can we assume that you're gonna grow kind of nicely? We need to, okay. Fine, we'll try this problem. Screw it, we'll try this problem. 3500s, older ones are easier. We'll look at it. We need 998 mod. Because I'm not satisfied with D, I suppose. Wait, is it D or? No, it's E. Okay. Wait, that was an E? That was a div 1 E. Sure. We'll toy with this problem. We're probably not going to solve it, but okay. Eval dom vector PLV. Max take ij as 1. Okay. C and N. Multi-chests? No. What? Yeah. VL res. P is N. Are you all distinct? Yes. Make sure you actually work. I is 1. R is 63. Sorry, what? Oh. Good to know. Okay. Good. Stop. PR. So I don't care about ants. 40. Bro, I'm a clown. Okay, so second derivative will be constant until we get an intersection. Second derivative will be constant until we get an intersection, right? So like 220, 0, 0, 1, right? Second derivative will be constant until we get an intersection. So that's 8. And that's 8 again. Wait, what? Oh, yes. So 16. Yeah, okay. So 16 up till a point, then 8 up till a point. PR is 0. R minus PV minus PR. Okay, yes, here we go. What? Really? Wait, that makes no sense. What? Huh. Okay. 4, 100, 55, 20, 3, 6. 32 are you mostly constant? Okay. If run R This is going to take forever. Okay. You don't need to be that big. Stop. Stop. What are you doing? Stop. Okay, yes. Okay, so count as 0. Okay, so we just need a fast eval function, right? So if we can eval an n squared, we need a fast eval function. If we can eval an n squared, that's fine. So like, so we store all breakpoints. Then, okay, so, okay, can you not? Can you please close? bp dot insert. We need VL. Push back x minus t. bp dot push back x plus t. Okay, now, for I is 0, I plus 1 is less than BPI size, I plus plus, x equal to BPI, y is equal to BPI plus 1. Okay, now, yell at for auto RC. If this is CR, doesn't matter. So we push back x plus t. We push back x plus t plus 1. Okay, and then this makes sense. If abs c minus x is less than or equal to t, L last y is equal to negative 1e12. Well, L is equal to r minus t. Crap. Wait. LV, RV is equal to R plus T. So LV is max LV last y. Last y is equal to RV. Yes. Last y is equal to RV. Okay. Ants plus equals y minus x times curve. Can we expect this code to work on the first try? Holy crap, it does. Holy crap, it does. Nice, okay. All right, good. Holy crap, it does. Let's go. Okay. So now we can do this so much faster. Yeah, this is infinitely faster. Okay, 50 k equals 100,000. Okay. Cool. Okay, so perfect. So now all we need to do then is do this. So we find the second derivative. Wait, how do we have the second derivative at? How do we have that? Wait, hang on. Why? Okay. So we evaluate you at 0. We evaluate you at 1. We evaluate you at 2. We find the second derivative. We count for how long that second derivative is maintained. We go through for how long that second derivative is maintained. Then okay, so the formula for the second derivative, right, is so it's a plus the derivative so it's a, so it's the initial point plus the initial derivative times m minus 1 plus the second derivative as a function of what? Plus the second derivative as a function of n minus 2. Plus the second derivative as a function of n minus 2. Right. Plus the second derivative as a function of n minus 2. So in one step, it's going to increase by x times in 2 steps, it's going to increase by x times 2 times 3 over 2, etc. Yes, okay. So okay. For L I is 1, I is less than or equal to k. A let's do this. Map if cache t okay, so this is stupid. dA is b minus a, dB is c minus b, dr is dB minus dA. So L is I, R is k plus 1. While L is less than R, M is L plus R over 2. L proj is A plus dA times M minus. So if projected is 5, if we're estimating from 5, right, then we need to make 5 steps. So M minus I minus 1. Then if the second derivative is 400, if the second derivative is x, right, then for 1 plus dr times, it's M minus M minus I plus 1. What are you? Wait. M minus I minus 1, right? So you're going to step up by 1. M minus I minus 1 plus 1. Over 2. All R is eval smart. Eval smart. Well, T is eval smart VM. If T is equal to proj, L is M plus 1, else R is M. T is equal to proj, L is M plus 1, else R is M. Okay. While I is less than R, M minus P, M minus P, I minus P. Proj minus PV plus mod. Ants is equal to ants plus I times x mod. PV is equal to proj mod. Okay. Yeah, plus I. Damn. Okay, we need that old loop back. for Li is 1, I is less than equal to Ki plus plus. We need that old loop back. R is eval smart vi. Okay. This doesn't even work, right? No, it doesn't even work. You're actually close though. So PRMT project. Are you like off by something? Proj is 2050. I is 1. A, DA, DB, DR. I is 1, R is 11. Okay. Okay, stop printing. Cool. Right. So we don't really need to print you. Cool. Okay. Make sure you actually work. How fast are you? Cool. All right, let's see it. Could you overflow, actually? This could overflow. I hope not. Nice. Okay. That's the 3500. Cool. Very nice, very nice. Interesting problem. Why don't I use CPH? Because effort. I don't know. No particular reason, just because I'm used to this. Because I do so much like local like BSing anyway that like I need my terminal, man. I need I need this control. I mean, I'm sure it gives you a terminal, but no, actually, that's not the issue, right? It's just, it's just status quo. That's the thing. It's just status quo. I barely even know what CPH is. It's just status quo. Morning. Morning indeed. Okay, so hope the second derivative doesn't change much. Turns out it doesn't, and therefore we're fine. Cool. And I guess, like, I mean, it's not going to overflow, I guess, which is cool, but yeah. 5,200. All right, and it just works. 400, yes. And that's like the big test, right? And you have some, like, you have this test, which is like all the points. You have some stuff going on here. No analysis whatsoever. Just hope the second derivative doesn't change that much, and you're good. That's all. That's all you have to do. Cheater, yeah. Well, okay. That's my first 3,500 in like a long time. Let me check that. How long has it been? How long has it been? How long has it been? Okay, it's been 2 months. That's fine. Whatever. Whatever. Yeah, I just want to stare at this now. This is cool. Good stuff. 92. Cheater indeed. I kind of am a cheater, yeah. I mean, it's an old 3,500, so like, I don't know. It's this would not be 3,500 now. I mean, this wouldn't be on a contest now. Like, nobody would give a problem like this, but meh, whatever. It's cool. Kind of just want to stare at these tests. Very nice. You just have like big numbers. Yeah, it works. Works very fast too. Works like, I mean, I don't think you can have tests that break my solution really, right? Like the second derivative can't take that many values, you know? Consider joining dark mode gang. No, I like blasting the eyes of everyone who dares look upon my stream. That's the intent of it. That's the point. What's it with these 2 points? Interesting. They can check, do we know the area of a square? That's what this test does. This checks, do you know the area of a square? And apparently I do, so that's cool. Okay, I'm on Adrenaline Rush now. Damn. That's cool, man. 3,500. Ugh. Well, yeah, I mean, you just take a div1f and solve it. Okay, I guess we can just do that. We can just do that now. How long has it been? How long was that? That was 40 minutes? Are you kidding? I am a cheater. I am absolutely a cheater. Yeah, you gotta accuse me of hacks. Y'all gotta get me banned. There's no way this is happening. Y'all gotta get me banned, man. Is it overcounting or undercounting? Well, that's the first real test, so. I mean, it's basically the, oh, Massey. I see. Wait, really? That works? Does that actually work? I guess that works. I guess you can just, do that. What is M? Num ants is f of t times t. And oh, yeah. Sure. Yeah, you look at the intersections and that's fine. And you hope that it doesn't change that much. That's pretty much the same thing. Oh, he just, okay. I see what's happening. He's just doing the same thing pretty much. Instead of binary search to find the intervals, you just look at the intersections and hope that the function is nicely behaved. It is. I guess you can just evaluate it like a linear occurrence, which I guess makes sense. It's a second derivative. I mean, it's a constant second derivative. I guess that works. Is that intended? Like, what's intended for this? I kind of want to see what's intended. F of t, yeah. T f of t. No. Oh, right. Huh. Okay. Interesting. Only n initial trees are burnt. So the result is just a second degree polynomial. I actually compute the coefficients of this polynomial by interpolation. Consider the function on the segments when it behaves as a polynomial. TF of, oh god, okay, I gotta remember that. I gotta remember this transformation. That's true. I forgot that was a thing. If t was 10 to the 9th, then yeah. Right. Sum of I times f of I, right, is sum of I times, I gotta remember that. I need to remember that. Sum of I times f of I is wait, what? Sum of I times f of I. Oh, right. It's freaking yes, it telescopes. It doesn't telescope, but it sort of telescopes, you know? You have sum of I times f of I minus f of I minus 1, which means that you have t times f of t, and then that, yeah, everything else becomes negative. Sure. Everything else becomes negative 1. Right, you have, 0 times f of 0 minus f of negative 1. And you have 1 times, yeah. Right. Okay. Doesn't matter. All we need to do then is evaluate this polynomial. Do I want to fund 3100? Not really. Maybe. Define fun. Fun for you is different from fun for me, right? Are you giving me an ICPC? If you're giving me an ICPC problem, I'm closing it. So this is t plus magic derivative cost. This is t plus like n to the 4th something, which I guess is fine. Wait, no, t plus, it's n eval, one eval is n squared. There are n squared points. So it's t plus n to the 4th log n. I guess you could cut out the you could cut out the t part by optimizing this loop, but you don't really need to do that. If you're giving me an ICPC problem, I'm not going to open it. Also, you can't send a link. Send it on Discord. It's thinking. I don't trust you. I don't trust that for a second. Not from ICPC. Oh, this was their round. Oh, this is the Edu people and Endogorian. Interesting. I trust Endogorian. Who wrote F? Who wrote F? Did they say that? Endogorian wrote the tutorial, so I guess that's fine. length n of elements 1 to 2. 2n minus k, such that pi is not equal to I. Why is that equivalent? Number of ways to complete the row. Oh, okay, yeah, sure. Sure. Somehow you subtract. That's crazy. that's actually crazy. Sure. No, yeah, it's derangements. It's freaking derangements. This makes more sense. Yeah, this... I don't know. I solved it my own way, whatever. I'm not trusting it. Give me... Okay. I'm not trusting it. It's late already. It's late. Kind of having this issue where I just lose my drive near the end of the day. It's kind of annoying. Why should I trust? Why should I trust that? Why should I? Why have I solved div 1, div 2, A, and B? But none of the others. Interesting. And this one we looked at. Oh, this. The fair nut round. Holy Christ. So D got no solves. Like, no solves. No solves. Maybe the string one? Call subarray LR a sequence of consecutive elements on an array with indexes from L to R. Subsegments intersect, and each element What in the world? There are 4 pairs of good subsegments. Call subarray LR a sequence of consecutive elements of an array with indexes from L to R. Subsegments intersect. Each element that belongs to the intersection belongs each of segments only once. So if we know L and R, if we know the intersection, then that's kind of hard. That looks kind of hard. Interesting. Aaron solved it. That doesn't mean I can solve it. That's not an equivalence. What in the world is this contest? So F is 3,300. C is what? How many sols does C have? 12. C has 12 sols. So C is like 3,000. This... What is going on? This contest is a mess, dude. Oh, this contest is a mess. It could hurt to try. It could cost me my sanity. Could very well cost me my sanity. The root in node 1. Let's define a function mex s. Or s is set. Okay. So are you being unsarcastic about fun? Like, are you actually claiming it's fun? That'll be a simple path on this tree. So find indices of nodes which lie on L as U1 to UK. For 2 nodes I and J, swap Pi and Pj. For 2 nodes I and J, swap Pi and Pj. Okay. Swap. Can we do something with it? Fine, give me the problem. I'll look at it. Send it on my server. Fine, I will look at it. Send it on my server because I'm going to open it on stream. Wait, am I going to look at this round? Hang on. What is this round from? I don't like it already. All right, whatever. We'll look at it. Fine. I've looked at. Why have I looked at this? Okay, cool. City of F can be represented as a tree. A famous fugitive is hiding in it, and today a faithful police officer decided to catch him at all costs. The police officer is stronger, but the fugitive is faster. Moment t equals 0. Selects any vertex. Fugitive aims to be caught as late as possible. This does sound fun. Okay. What? Is the image broken? I guess the image is broken. Whatever. Probabilistic strategies, huh? I don't need the image of the tree, it's fine. Okay, so I mean, if the officer doesn't go into a leaf, then, like, what's the point? The officer has to go into the leaf, otherwise the fugitive can just hide at a leaf. So, given that, given that what? Since it doubles, we can do some convergence nonsense. Just a note there. We could do some nonsense. I see some nonsense happening. N equals 105 seconds. That's kind of weird. We can definitely do some convergence nonsense. Number of vertices in the tree. The next n-1 lines describe the city of F. Each of them contains a pair of integers ui, vi. The number of the vertex where the police officer initially appears. So I mean, if I'm at some leaf, famous fugitive is hiding in it today, a faithful police officer. So sure, we consider rooting at every vertex. Suppose the police officer is here. Let's just consider the initial starting state. All right, so assume we root at this vertex. Would we ever want to backtrack? Like, would the police officer ever want to backtrack? What the hell is the optimal strategy for this? I mean, suppose we did backtrack, then it'll just be a waste of one of our moves, right? .3525. That is the answer. Interesting. So ultimately, it seems like I'm going to assume for now that the police officer is going to bounce between leaves. If we don't go to a leaf, then what's the point? If you go right next to a leaf and then you go out, then like don't. You know? If you ever backtrack, like don't. Just don't have done it initially. So assuming the police officer is going to bounce between leaves. You're aiming to find a probability distribution of ending up at these leaves. So given that we start at some vertex x, then what is the probability of okay, so we're assuming the fugitive is going to be on a leaf at any point. Assuming the fugitive is going to be on a leaf at any point. Because why not? So the question is, which leaf do they go to? So if the fugitive is under the police officer, then fugitive is under the police officer. And they're going to go to a leaf at random. Why did you give this to me? Oh man, this is not my type of problem. This is a problem I would pawn off to my teammates if I got in contest. So we're looking for some equilibrium. Right, we're looking for some equilibrium. So if the fugitive chooses to go somewhere like if the police officer has some distribution, and the fugitive goes somewhere that doesn't maximize the sum given the officer's distribution, then they wouldn't do that. I've solved a problem like this before. Wait, hang on. Wait, hang on. Wait, hang on. Wait, hang on. There's a it's not the same problem, but it's like policeman in a tree. Yeah. It's it's kind of criminals can move with arbitrary large speed. This is similar, except one direction of positions aren't known. Why would we not be able to catch the criminals? Yeah, so that's fun. And we're looking for an equilibrium here. I don't know, man. I don't know what makes an equilibrium here. Can we do repeated Gauss until we find an equilibrium? Would that work? I that kind of looks promising, actually. That kind of looks promising. I mean, surely there's a way to solve this, but maybe we just don't need to. I mean, like, we have some... For each leaf... Okay, for each leaf, there is some expected time to finish after this leaf. And we need to set up a system of equations with these, and then we could solve that, right? But for each leaf, there's an expected finishing time from that leaf. And there is some optimal distribution of probabilities. Some choices to make for each leaf. In particular, like the way this game is going to play out is the fugitive is going to pick a leaf. The police officer is going to go towards that leaf. It's going to go towards some leaf. If the police officer guesses wrong, then the fugitive is happy. Otherwise, the fugitive is not happy. And this continues indefinitely. We're going to pick some leaf. So we just need to find the probability distribution, right? Can we model this as Gauss? Like we have E of V is P of, no, that's too big. That's n to the sixth. That's not gonna work. But I mean, fundamentally, we have this system of equations. E of x is the sum of probability of going to x times the distance plus, that's not linear. What am I saying? That's not even linear. Okay. Yeah, that's not gonna work. Probability of going to x times the distance plus E of u. So it's the probability of going to u times E of, yeah. So if we know the probabilities, if we can determine the optimal probabilities, then we can determine the optimal equilibrium. Okay, you're lucky because I don't want to do this problem. I don't want to do this fair nut thing. We'll do it tomorrow, I guess. How does this work? Like, where does this go? Decorate apple tree. Check transcription. What in the world? Why does D have so many solves? D has more solves than C. Interesting. I guess we're gonna do all of these problems. I guess we gotta try 3500s now, huh? I guess we gotta do that. That's cool. Problems have gotten easier. Represented as a tree. Famous. Are all the problems lettered? Yeah, nice. Cool, good stuff. Fuse self-certain has nothing but the fugitive's movements. Right. I don't know how to find these probabilities. All right, the probabilities depend on the expected values, which depend on the probabilities, which, you know. And there are n squared such expected values. There are n squared such probabilities. Okay, how about we do some convergence stuff? So we fix that each probability is equal initially. How about that? Then if each probability is equal, then we're going to prefer. No, but it's like it's equilibrium. It's how do we model equilibrium? The only property of the tree that we're using is distance. ADHD twin. What? ADHD. Nice. What happened? This is a bit of a dissonance for twins. Nice. Yeah, could work. I mean, the whole point is accountability, right? So, could work. Yeah, I mean, streaming's not going to save passion, but it will, like, it'll stop you from. It should prevent you from being lazy. Yeah, sleep is going to be a thing for sure. I don't know what's up with that. I don't know why is that happening? Wait, sorry, I got a bit distracted. ADHD project, yeah. Yeah. Okay. First line contains an integer. Okay. It's too messy for me. This is too formal. I don't know, man. I don't know how to set up equations for equilibriums and do that. Are you supposed to solve this optimally? Like, are you supposed to actually solve it, or are you supposed to do it mathematically? Because, I mean, I know the ultimate thing is you find the probabilities, you set up a system of equations, you do that. That's fine. But how are you supposed to find the probabilities? Also, wait, like, no, don't give me spoilers. I'm probably not going to solve it tonight, but don't give me spoilers. I hate spoilers. It's just going to make it worse. I'm not equipped for this type of problem, though. I will say, like, this is not the type of thing I solve. Next, n minus 1 lines describe the city of F. Each of them contains a pair of integers ui, vi. The numbers are the ends of an edge. Edges are guaranteed to form a tree. So we're going to pick two of the vertices. They're going to be equally probable. Fundamentally, like, farther vertices. I mean, wait, if we're going to have an equilibrium, then we can factor in the expected duration into the like the expected benefit must be like the expected benefit for going to a leaf is going to be the same. Because if it was better for one, then the police officer would weight that one heavier. And thus, the criminal would weight it lower. and thus stuff. So I mean, I can tell that if every leaf were at equal distance from each other, like if it were a star graph with arbitrary depth, then every node would be equiprobable. But of course, that's not true here. So somehow we find an equilibrium. Somehow the benefit of every node is the same. The expected length plus the distance is the same. No, it's okay, so it's the probability of the crook going there. So like if we're at some node S, the police officer going to J, the probability of the crook being at J, probability of the crook going to J. Maybe we don't need, so it's the probability of the crook going to J. Plus 1 minus that probability. So it's distance. It's distance plus the probability of the crook going to J plus 1 minus that probability times the expected value. And these expected values must all work out to, well, whatever they are. You need to form an equilibrium with the probabilities. So it's distance plus 1 minus p times e for each node. E is some fixed value, some fixed unknown. We need that d plus 1 minus p times e. Is equal to 1. We need the sum of probabilities is equal to 1, of course. And then what are the police officer's actions? And the police officer wants to as a police officer, choose one action over the others. So they have to all be equal, right? They have to all be equal. We don't know the weights. crook must act according to the police officer's actions. So I mean, I'm thinking about like fixing it at the first turn. Fixating it at the first turn. And given the police officer's actions, the police officer's probabilities must make it so the crooks are the same. The police officer's probabilities must make it so the crooks are the same. Which type of... I don't know enough about game theory. Which type of equilibrium are you looking for? I took a freaking class on this and I still don't know it. Mathematical expectation of the duration of the chase. Police officer acts to minimize the expected duration of the chase and the fugitive to maximize it. Find the mathematical expectation of the duration of the chase with optimal actions of the police officer and the fugitive. The officer's probabilities. Yeah. I mean, since it's zero sum, probabilities kind of have to be the same, don't they? Since like the cost function is going to be the same. So for there to be an equilibrium, the expected payout must be the same for every vertex. So it seems like the officer and the fugitive strategies have to be the same, but I don't see how that helps, really. Don't really see how that helps. Ugh. I have this song in my head. I don't know where it comes from. Like, it doesn't come from anywhere. It's the strangest thing. Like, it's not from anywhere, but it's in my head regardless. That's weird. We're getting a new president this year. Oh, God. This is cool. Existential writings. Nah, I don't know. I don't know how that thought entered my mind. I just like it's 2024. Like something. I don't know. Some things are gonna happen. That's yeah. AI Doom. Yeah, I'm sure that's common. AI president when? Huh? When is that gonna happen? Okay, I'm kind of done with this problem. I don't know. It's fun, but I wouldn't call it fun. It's not for me. It's not my type of problem. I don't have expectations for it. $2024, yeah. Something's happening. Okay. Whatever. This problem's fun, but I don't really want to do it. Yeah, president. Oh, I see. Yeah, sure. Let's hope. Be better, probably. GPT-5. Let's go. Let's see it. Let's see it happen. Did they sell this in contest? Oh, they did. Nice. Good stuff. Well, I'm not going to solve it in contest, so whatever. Yeah, I'm gonna leave it. Okay, that's enough for today. Good stuff. Good progress. I'll call it. Anyone who wants to talk, Discord, but nobody does that anyway, so whatever. Okay, bye.